We'll get started. If you guys want to write down a few things, you can. The slides are posted. Oh, we're trying something new today. I hope you all have your iPad. You need to log on to Class Kick. We're going to try something new. Virtual students, this is a good heads up for you. What I'm going to do today is give a term or show something new, show an example, and then you are going to do it on Class Kick right after I show it in the middle of our slideshow. So instead of waiting till the end to have you do a bunch of problems, you're going to kind of do them as we go. You're going to do the Class Kick as we go. So what that means for a virtual student, if you're watching this video, is that when I put the slide up for like a practice problem, it would be good to probably try it, but you might want to fast forward a couple minutes because I'll give them 2 or 3 minutes to work on a slide, and then we'll keep moving. So there's going to be more dead space in this video. Does that take you to a Class Kick? It should. That code should still work. But you don't need it like this second. So you can just log in and hold up for a second because you don't know how to do that. Well, you probably can figure it out, but I've not showed you how to do that problem yet. So let's do a little review. On 10.3, so way back last week, we learned what the Pythagorean theorem was. Well, maybe not learned what it was because you guys already knew what it was, but we reviewed it. Joe, you tell me, what is the Pythagorean theorem?
A squared plus b squared equals c squared.
Yeah, perfect. And what type of triangle do we, yeah, right triangle. It has to be a right triangle. And then Leighton, what letters, well, what are the legs, first thing? A and B. Yep, and what do the legs make up? Like, how do we know which lines are the legs? Yeah, they make up the right angle. So we could say A and B, or we could say A and B. It doesn't really make a difference. But good, that's our Pythagorean theorem. And then C is our hypotenuse, kind of as a given. It's across from the right angle. Perfect. Today we're going to learn a new term of what a converse is. Have you guys heard that term in math before?
No issues.
Do what? Yes, they are shoes. But we're going to learn what the term in math, a converse, means. And then look at some things with the Pythagorean theorem. So what's a converse? Converse of the Pythagorean theorem. Oh, I forgot. We're learning distance formula today. That will kind of be a big thing. That would be cool. But it's not very overly difficult. First, let's look at what a converse is, or what a converse means. The converse of a statement switches the hypothesis and the conclusion. So, like it says, if we have a statement that says if Joe studies for his test, then Q, or if Joe studies for his test, then he will do very well on the test. That could be our statement. We have a hypothesis and a conclusion. The hypothesis would be if Joe studies for his test, then he will do very well. The converse of that statement would just be switching things around. We would say, if Joe does very well on his test, then he spent a lot of time studying. So the converse just changes around the order of our statement. A more math example would be like in the second box, if A equals B, then A squared equals B squared. The converse of that would be if A squared equals B squared, then A equals B. So like it says too in this last line with the converse might not always be true. Like it says, a counterexample or something that shows that the converse is not true is that if A equals 2 and B equals, or A equals negative 2 and B equals 2, right? If A is negative 2 and B is 2, when they are squared, they equal the same thing. So this is true. But then the second part of it, negative 2 is not equal to 2. So the converse is not true. But the original statement is true. So I don't want to get too far into is the converse true, is the converse not true. I just want you to have an idea of what the term converse means. It's switching around our hypothesis and a conclusion, or switching orders of a statement. And that's what we're doing with the Pythagorean theorem. So we're saying, when we have looked at the Pythagorean theorem so far, we have said that if we have a right triangle, then this statement is true. Whoops, equals c squared. Right? We have went in this order. If we have a right triangle, then a squared plus b squared equals c squared works. Now with the converse, we are going in the other order. So we're saying if a squared plus b squared equals c squared, if they give us some triangle where a squared plus b squared equals c squared, then we know for sure that it is a right triangle. Okay, do you see how we're switching the order of things? They're giving us some triangle, and they're going to say, hey, is this a right triangle? And we need to use the Pythagorean theorem to show whether or not it is true. That is our converse. Does that make sense? Kind of blurb? A little bit? Joe?
Yeah.
Dave? Chris? So let's look at an example. Classic question. Tell whether each triangle is a right triangle. Well, they don't give us the little right angle sign, right? That would be our first hint. So we need to set up a squared plus b squared equals c squared. And if this is true, right here, then we know that we have a right triangle. So a, b, and c. So 24 squared plus 7 squared equals 25 squared. Who has a calculator? You don't have a calculator? We can pull up a calculator. What's 24 squared? And 25 squared. They can find 24. Whoever else, I can't see what Joe's got on the screen. If you get into a calculator or not, but someone get 25 squared. And I can do 7 squared in my head, so we're okay there. 24 squared? 5 squared?
625.
Whoa, what?
625.
Okay. 625. So what is 576 plus 49? Anybody? What happens when you add 576 and 429? We do? So 625 equals 625. So that means that letter A is a right triangle. Does that make sense? We're using the Pythagorean theorem backwards. Now, letter B, it's a little bit harder to see, I think, which angle could be our right angle, so what our a squared and b squared should be. But how do we know that if this is a right triangle, if letter B is a right triangle, how do we know where we might put the right angle and what A and B should be? Like, how do I know if I'm setting up 40 squared plus 90 squared equals 80 squared? Why? That's what I'm trying to get at. Why would this not work? Or why do we know for sure that even if this was a right triangle, that this would work? What does C have to be? What? Yeah, our C, or our hypotenuse, has to be our longest side. So when we're setting this up, we need to make sure that if there's any chance that this is a right triangle, it would have to be right here because that is our longest side. So it would have to be 90 squared equals 40 squared plus 80 squared. Layton, take 90 squared, Joe 40, Lerp 80. And then let me know once you get what that is.
1600.
Yeah,
Did you get 90?
yeah, 80.
And then I think we have this right here. This would be 8,000. So these are not equal. So that means this is not a right triangle. What questions do you guys have? All right, I think this is the part where you do. Yeah, go ahead. Do slide 1. Take a second. Now they don't draw the picture for us, but we can easily set up our equation to see if that would be true. again, we need to make sure that the longest side is our C value to even give it a chance. What I'll do is I'll give you the worksheet. Once we finish everything, you'll make sure all your practice problems are done. I'll give you the worksheet, and then I'll check your practice problems just to make sure you're tracking. Hopefully doing these problems in between slides helps break it up a little bit so it doesn't feel like you're just listening to me talk for 25 minutes. Because that's like the worst thing ever, isn't it, Lerp? It was just 3 of us in here all year, with only 3 people in the classroom. We could be to chapter like 15 by now. We'd be moving quick. You guys good? All right. Even if you didn't quite finish, we will keep moving. All right, distance formula. Here's, you guys have not seen the distance formula before, have you? In 8th grade? You do? I'm not saying you should have. I actually don't know if you've seen this before or not. Joe, does this look familiar? Not at all? Okay.
I remember there was a difference.
Okay. I think this is something, the distance formula is something that we hammer in geometry. So I have geometry students who still aren't getting the distance formula. So if, not because it's really complicated, but I think if you guys can grab hold of this now, you're going to be in real good shape for GOA next year. But what the distance formula does, well, let's backtrack a little bit. If we look at this picture, if we are trying to find different lengths, if we have a coordinate plane, we're graphing something, we're trying to find different lengths of things, why is it really easy to find the length of the blue line and the red line that I'm going to try to fill in there? Why would those be really easy lengths to find? What do you think? Yeah, because they're just, we have a straight vertical line and a straight horizontal line. So we can just count the number of boxes, right? If this were, broken up like this, we would know that this is 1, 2, 3, 4 units long, right? Horizontal lines and vertical lines, we can just count how many units it is. Right, Joe? You tracking with me? I can't quite hear you, sorry. Yeah? Alert? Horizontal line, we just count how many boxes it goes across. Vertical line, we can count the boxes up. Now when we have a diagonal line, that's where we start to have some issues, right? Because we can't just count boxes of that diagonal line, okay? So that is where the distance formula comes into play. Because with the distance formula, we can take these points, we can plug them into our formula, and it will tell us how long that side is. So again, we really like horizontal and vertical lines, so we can just count boxes to find the length of those. Any type of line that's diagonal, then, or then we need to use the distance formula. Okay? The distance formula is we choose 2 points. We use the 2 endpoints. We decide that one point is the first set of points, the other point is the second set, and we plug some things in. So this example will make it not too bad. Find the distance between those 2 points. It even tells us let x1, y1 be the first set, x2, y2 be the second set. So if we were to just, we don't have to graph these in order to solve, but I think it kind of helps. At -3, 1, 2, 3, 4, 5. Point here, and up to -1. So that's our line, and we know the distance formula is to find the distance of that line, square root x2 minus x1 squared. Was it plus or minus? Somehow plus. And it says that we are going to have x1, y1, x2, y2. So now we just need to plug these things in. So what is the value? I'm just plugging things in. Joe, what is x2? What did it tell us that x2 was? Yeah. Lurk, what about x1? What? I thought you mumbled the right number. Yeah, -3. Leighton, what do we have for y2 and y1? -1 minus what?
Sine.
Perfect. So we just plugged in the numbers that they gave us in the question, right? Now if we simplify, we have 2 minus a -3. So minus a negative means plus. 2 plus 3 is 5. 5 squared would give us 25. -1 minus 5 is -6. -6 squared is 36. Someone get a calculator. 61? So the square root of 61 would be some decimal. 7.7 or something like that. 7.8. 7.8. About 7.8. So do you see how with the distance formula, we take our 2 points, we decide, all right, here's my first set of points, here are my points that are both going to be 1s, x1, y1. Here's my point that are both going to be 2s, x2 and y2. We plug it in and simplify. It's not anything that we haven't done. I mean, we haven't used the distance formula before, but we've plugged points in and we have subtracted, we've squared, square rooted, all that good stuff. So nothing too insane here.
I think we did some similar to this in 1A.
Okay. Yeah, I didn't teach 1A. I wasn't here, so.
There's something to do with x2.
Slope has x2 and x1. So that could be what we're thinking of. So here's the question. Find the distance between the 2 points. The first thing that you need to do, and this is on your class kit, I would say that, well, yeah, you can definitely graph. Well, I guess it is